that too. He's like, don't feel bad because he's just fragile. And I said, okay.
All right. For today, we're going to follow the following 4 steps as our main way of focusing on how to graph each of their functions. Now, these steps, I recommend doing them in order. That does not mean every step is required, because for some parts of the function, like this is just not necessary. We're going to start with some really basic ones. We only really do one major change at a time. Then we'll start combining multiples of these together, in the hopes to see that what we can do is we can have multiple changes. The more complex the function is, the more these changes can happen, but they still follow the same basic rules. So, I list them in order in terms of ease, but in terms of graphing them, it's better to kind of go in reverse. So that's what I'm going to do. Now again, to start with these particular 4, this works for either sine or cosine. It is, as always, helpful to have a clear and permanent understanding of what the 2 regular functions look like. So I'll put an example of those on the board. Normally, sine starts at the center. It travels up to the amplitude, travels down to the negative amplitude, and it comes back up to the center. That is a good way to think about it, rather than thinking about it in terms of the hard numbers. So for sine functions, we start on the midline. We travel up to the amplitude. We then travel down to the amplitude, passing through the midline, and then come back to the midline. So again, it starts in the midline, goes up to the amplitude, goes back to the midline, goes down the amplitude, comes back to the midline. And it does all this in one period. So if I can then determine where it starts, what the amplitude is, where the midline is, what the period is, I can use this basic shell to graph any sine function. Let's compare this to cosine. Cosine, instead, starts on the amplitude, travels down to the midline, travels down to the negative amplitude, travels back up to the midline, and back up to the amplitude. So again, sine starts in the midline, comes up the amplitude, goes down to the midline, goes down to the lower amplitude, comes back to the midline. Cycle. Cosine, on the other hand, starts the amplitude, comes down to the midline, comes down to the negative amplitude, comes back to the midline, comes back to positive amplitude. It follows the cycle every time. So if I can determine each of these pieces, where it starts, where the midline is, what the amplitude is, the period is, it's just a matter of filling in all these little blanks with numbers. That's how I'm going to approach it. I'm going to approach it by trying to find all those with the formulas we talked about last time, which will be helpful here. And then afterwards, once we have the formulas, we can apply it to a graph. These graphs will be unique. The phase shift, as a reminder, was C over B. The midline was D. The amplitude was the absolute value of A. The period was 2 pi over the absolute value of B. So as a reminder, use each of these today as we approach our problems. Now, like I said, we're going to start easy. As we go through today, get progressively tougher. We'll mix and match. Sometimes we'll do sines, sometimes we'll do cosines. But the main premise is going to stay the same. If we can answer these tiny questions and put them onto our picture, it's just a matter of connecting a bunch of dots. So, let's see what we got. First one I want to graph today is sine of 3x. If you haven't got it calculator, you're welcome to check this whenever you're finished. Please do so. What we're going to do now, though, We're going to attempt to answer each of these component pieces. With these answers, we're going to attempt to build the shell of this trig function and then put all the pieces together. Let's do it. To start off with, let's answer those questions. Question 1. What's the phase shift? In other words, how much has it moved left or right? None. It is not moved left or right. The B value is a 1. The C value is a 0 since it's not there. 0 divided by 1 is 0, so there is no phase shift. There is no movement left or right. What about the midline? How far has it moved up or down? None. There's no number on the outside. Next. Amplitude. How far is it stretched up and down? None. And how is the period changed? What is the new period?
Taylor Barnett, please come to the office.
No.
Taylor Barnett, please come to the office.
Not 1/3 either. The new period is 2 pi over 3. Remember, you plug the b value into the function. So it's 2 pi over 3, so that's our new period. Meaning we'll take exactly 2 pi over 3, we'll graph this function. Now it's helpful to look at this picture and think of it in pieces. So now I'm going to attempt to go back to sine and cosine and point out a couple of very simple facts about this. Halfway, remember this is one full period, right? Halfway, it will cross the midline. A quarter of the way, it will be at the top. Another quarter of the way, it will be at the bottom. So if I look at this picture, there are 4 points of interest. And these take place if we have a full period, halfway, at 1/4, and at 3/4. So if we know what the period is, we can actually draw everything else using that simple idea. Something unique happens, something predictable happens, half of the period, a quarter of the period, and 3/4 of the period. We're going to use this to draw the structure. So, how on earth do I take all these questions I've answered and put them into the picture? Well, I start from the beginning and start to build a grid. Here we go. First step, I begin by drawing my x and y axis. It is tradition. Make the x-axis longer. It'll make your life easier. I promise. So, next. I'm going to put the midline in. And what I'm going to do is I'm going to do some coloration up here. These things are fantastic to put in your pictures too. These are temporary, what I call construction lines. I mean, they're going to help me draw more of the problem later. What I'm going to do is I'm going to put, in this case, the amplitude in green. I'm going to put my midline in blue. In other words, what's going to happen is my function is going to bounce between those 3 lines. It's going to bounce between the 2 amplitudes that I'm going to put in and constantly crossing that midline in the middle. Take a look. So my normal midline is at 0. My midline, in this case, is going to be on the axis. My finished function, when I'm done, will be put in black. So you can see that it's going to be clearly separate from everything else. The rest of this is just construction to get it all right. Now, where's the top of this function going to be? It's going to be at the amplitude. The amplitude in this case is 1. It's the maximum height. It's a number that's out front of the function. So in this case, the number out front, there is a single sign here, so the top value is a 1. So up here, there's the top of it's going to be. Up at the lower amplitude, a -1. So what I've done is I've taken the midline, I put that in first, then I put the amplitude around the midline. Now I figure out how to fit it in between. What I want to do now is place the starting and ending spots. Where does this function start? Well, There is no phase shift, so it's going to start at the origin. So it's going to start right there. Where is it going to finish after one period? 2 pi over 3. Remember, after one period, it'll have started at the origin and gone one period length. So this is going to end, and I'm going to give it, I'm going to just throw 2 pi over 3 down there. How far down there? Yes. Yes. As far as you want to put it. Put it so you have enough space to draw. Unlike with algebra, where you're constantly like, each brick is 1. No. Be smart. Because if you try to count by ones on this thing, where's 2 pi over 3? I don't know. Okay? So instead, we just make it a system that's going to be easy for us. What I like to do, my personal preference, is to put it at least multiples of 4 away. The reason being is because if you look up here, right, I'm going to break it into half and into fourths. That's how I'm going to let this thing fall apart. So what I might do is I might put it 4 bricks away, or I put it 8 bricks away, or if I want to get really fancy, 12 bricks away. Because we make it real simple to line up every other number. Remember, my focus is getting the graph to look right, not worrying about what the numbering system is. So up here, 1, 2, 3, 4. I was a little off. I'm going to fix that right now. Again, I want to make it as convenient for myself as I can. So 4 over, 4 over. I'm just going to claim that's 2 pi over 3. Again, I'm looking for ease. Now, sine starts on the midline. So it starts in the blue line here. And it ends on the period and on the blue line. So this is going to end right there. So I now know where this thing starts. And I know where it stops. For again, one period, the first period. Okay. Now there are 3 more points of interest. Halfway in between for the sine function, if we look up here, halfway in between it crosses that midline again. So we go to my midline. Halfway in between, it's going to cross again. And now I can use my system to kind of help estimate that. If I know a full period is 2 pi over 3, half of that is going to be pi over 3. This dot takes place at pi over 3. Yes, it can be intimidating when you look at the end result especially. What's best here is take it again, one piece at a time. And we're going to focus today upon building a script we're going to try to follow every time. So we can build a way to always find our solutions. So again, what we did was, we determined these first, and then we graphed the midline. That was our first graphing step. Then we graphed the amplitude off the midline. Then we determined the starting place. That's where the phase shift is. And then, once we get the phase shift, we use the period to find the end. Those are the steps we followed so far. And now to get every other point, now we're just using properties of the function rather than trying to worry about exact values. So notice that I look at my picture and I go, okay, what does sine look like? Starts at the origin. Halfway through its cycle, it's going to hit the midline again. At the end of its cycle, it's going to hit the midline again. So I've got 3 guaranteed points. Midline at the origin, midline, midline. Next step, talk about the tops and the bottoms. Where does the top go? The first thing it goes is it goes up to the amplitude. That's going to happen halfway in between this next cycle. So right there.
That word in red.
Start.
And stop.
And stop. Sorry, my handwriting is not great.
I just wanted to make sure.
Always. Slightly better. Okay. Notice how I'm using properties of the picture and properties of how I constructed this thing to make my job easier. I counted by 4s because halfway in between is going to go my midsection, and half of that is going to go my amplitudes. So over here, I do the same thing, halfway in between. I draw my bottom value. And now, I connect dots. Make it look like the sine function. It should be nice and curved.
Do we need to label the...
We will. We need to know where these 2 points are. So, to find this first one, I need the halfway point between 0 and pi over 3.
I was at pi over 4 or pi over 6.
Pi over 6 is correct. What you can do is just cut this number in half. Pi over 3 becomes pi over 6. What about halfway between 2 pi over 3 and just pi over 3? Close.
Pi over...
Be 3 pi over 6. Which is weird, because 3 over pi over 6 is actually pi over 2. This is where it becomes frustrating. There's a lot of little math that goes into this. It's not the math that's going to be hard, it's the little stuff that's going to trip you up. Okay. So now, let's look at where each of these dots is. I'm going to zoom in a little bit.
Ooh, ouch.
Top one.
So ugly now.
Thank you. Hey, don't talk about yourself that way. First dot is at 0, 0. Second dot is at pi over 6, 1. A little bit, but you're going to survive.
A lot.
Second dot, pi over 6 over 1. Third dot, pi over 3, 0. Fourth dot, pi over 2.
You guys know what you're doing because you're going to have to explain it to them.
Well, I don't know.
And last dot, 2 pi over 3, 0.
I'll get in here and he'll be like, what?
I'm just listing out all the points. Normally, I'll do this on a separate piece of it, so I have them listed out. Okay. Last one. Connect dots. Sine function is not a straight line function. It is a nice curve. Make it look like the sine function. It comes up to the 1, travels back down to the 0, down to the negative 1, back up to the 0. And all that work, get that little old line in black. I know. It's beautiful. Makes you want to cry, Slippery. In order to do this kind of technique, you have to have a concrete understanding of each piece and how it fits in the overarching picture. You have to have a good understanding of what sine looks like. But notice that no individual piece is tough. There's a lot of pieces to it. This becomes a common trend in upper mathematics. The math doesn't necessarily get much harder. It just becomes a lot of little problems that you have to put together the correct way. Making small mistakes can quickly get you. So note how we did this problem. Now we're going to take a soft reset. Like this one. One more time. We determined our basic facts about this function. This stuff, you don't have to put in the graph at all. It helps you get the graph. It helps you find out all these pieces. Where does the midline go? Where does the amplitude go? How's the phase shift fit in? What's the period going to do? You have to answer all these pieces before you can put them in the picture. Then we take that information and we start trying to apply it to the picture by graphing these little things. We graph the midline first. That's where the center of the function is. That's what everything else guides around. The midline comes first. Then we develop the amplitude off of the midline. How far above the amplitude does it go? How far below it does it go? We use the phase shift to determine if it moves left or right. We use the period to determine if it's shrunk or expanded. And again, we had those equations last time. They're there for a reason. They're there to help. All right. I said we're going to take our time.
Is this basically like, it's like, are we keeping this?
I would.
Okay.
These are fantastic examples to work through. And when I learned these, I did a lot of times where I did it by hand. They gave us a bunch of different colored pens to keep track of this stuff.
That's what I'm doing.
I think it works great if that's your thing. I have plenty of friends that did it without any of that stuff. I will supply what I can. If you need something to help you out with this kind of stuff or you have recommendations, I'd love to take them. Like I said, this is not one of those things that everybody is comfortable with. Not everybody likes to do the graphing portion. So let's see what we can do to make it better. All right. So I'll reset. Woo! How's your day going? Feel good? Want to cry, but don't want to cry in the classroom? You wait until you get outside?
It's going fine.
Just want to go home.
I just want to go home.
Oh my god, don't talk about it.
Okay.
Yeah, but I don't want it to be a weekend because I don't want to go to work.
I don't want to do a weekend. At least get paid to do that.
All right. Turn it back. 2 cosine of x. 2 cosine of x. Thanks for that. On the side over here, out of the way, I'm going to answer those top 4 questions. Again, this is going to help me determine all these little things I need to graph later on. So answering them first is a great place to start. So let's answer it. Go up here. Is there any phase shift? No. In other words, this function is not moved left or right. Where's the midline going to be?
I'm sorry.
Remember, the midline is any number being added or subtracted on the outside.
Yes.
Yes.
0.
So in this case, yes, it'll be at 0. So in other words, the x-axis.
Okay, what you said. This number on the outside.
Yeah, there is a number on the outside, is there? If there's a number on the outside, it tells you how much it moves up or down. If there is one, then it didn't move up or down at all.
What is he multiple?
When we did the last one, when we did 1, 2, 3, 4, what is that?
I should right here.
Is that the same thing?
What are these 4 questions? Okay.
How do you
Amplitude.
know?
How do you know? Remember, your basic form for these is a sine of bx minus c plus d. So if one of those pieces is missing, it tells you something about these values.
So we have 2 cosine.
So we have an a of 2, we have a b of 1, we have a c of 0 since there's no c, we have a d of 0 because there's no d.
How do we know? Okay, so the 1 is B.
Correct. Because there is a single x.
Oh my gosh. You be quiet.
He's more freaking about his own problems.
I thought he was laughing at me.
No, I'm right there with you.
Okay, don't make fun of me.
Alright. Let's take a second.
And
Let's
breathe.
compare. Deep breath. Calm. These ones can feel very intimidating. Take it one piece at a time.
Make
Okay.
it to a test on this, I'm gonna fail. I just want to.
Give yourself time. I have all the faith in the world in you. Okay, let's look at our function. Looking back at our example version. I can see I have a number out front. So that's going to be my A value. That's going to affect my amplitude. I see, yes, the amplitude. Let's put that on a list.
It's 2.
Is 2.
Pi over b. We don't have to.
So in this case, I plug in a 1 for my period. Because again, there is still a single x. There's one x up there. It's x, so there's one of them. So that means my period is 2 pi over 1, which is just 2 pi. Remember, this tells you how long it's going to take to go forwards and backwards.
Wait, what is different from cosine? It goes down first, right?
So let's look at cosine. As a reminder, the cosine function
Interesting.
Cosine function, as a reminder, looks like this. It starts on the amplitude, comes down to the midline, hits the underside of the amplitude, comes back to the midline, comes back up at the top. It's also visible up there. So, if I can determine where these four pieces fit into my picture, I can determine how to graph this function. So I've got my four pieces. We have three of us up here. We got it. There's no phase shift because there's no C. So it's not going to move left or right. So you got to think, this picture is not going to move left or right. The midline, there's no D on the outside, so it's not going to move up or down. It's going to stay where it's centered. It has an amplitude of 2, meaning it's going to stretch up and down. As the amplitude does, remember, it stretches it out. The period is 2 pi, meaning every 2 pi, this thing will complete one cycle.
Oh gosh.
Ready?
No.
Get ready. All right. Here we go.
So we're ending at 2 pi.
Okay, let's start in order. Midline first. There was no D value, so the midline is going to stay on the x-axis. So my midline, right here, is the x-axis. It's still the middle. The amplitude is 2, meaning we go 2 above the axis and 2 below that midline. So the top of this is going to be up here at 2 and down here at -2. So let's stop right here and discuss what we found so far. We know the center of this graph is on the x-axis because the midline is at 0. We know because the amplitude is going to touch up at a maximum of 2 and then bottom down at -2. All right. That's our next piece. Where will this function begin? Well, it's a cosine function. So the cosine function, as a reminder, it starts at the top of the amplitude, up there. So for ours, that means this function will start right here.
Huh?
Remember, it always starts at the top of the amplitude. Cosine starts at the amplitude. At the end, which takes place at 2 pi, click on a picture. I go 2 pi.
Could you just totally just like estimate that? Like just.
Oh, you think I'm being fancy?
No, like I'm just asking if you just put the line there or if like that's like where it's.
You had
You
exactly
reverse your
8
point.
the first time.
I put it at 8 because I'm going to use a trick to figure out the rest of this.
But you reversed your point.
Yeah.
Your black point on the 2.
Thank you.
Okay, so it doesn't matter where we put it.
Nope. I'm putting it here for convenience. Because remember, it's going to break it into fourths. Because if something happens every fourth. Take a look. At the start, we hit the top. Halfway in between, we hit the bottom. And then at each fourth, we hit the middle. So let's start filling in some buttons here. At the end of the cycle, it's going to end up right back at the top. So I now know where it's going to start.
Oh, shoot.
And where it's going to end. Okay.
Sure.
The middle's going to be where's at the bottom. Why is the middle going to be at the bottom?
Because it's cosine.
It's cosine. Cosine always has the middle at the bottom. Coming in the middle. It's going to be at the bottom. Now,
Both those will be at 0.
halfway between those will be at a 0.
Or the midline.
Where it crosses the midline.
I guess it could change.
You phase shift again. So let's hold on. Garrett's bumping ahead. I think he's got this. So let's catch up to him. Okay. First thing he said was, okay, we know where it starts and finishes. Boom, got it. Let's go there. So it says halfway between, based upon the picture, halfway point is going to hit the very bottom. It's going to be the bottom of the amplitude. So it's the picture. He says, okay, halfway in between. There's the bottom. It's halfway in between our two ends. It's at the bottom of the amplitude. Must be good. I'm put in 2 more points. Halfway in between each of these. And as you described it, where are those going to be at?
The midline.
The midlines. Right there. And right there. Okay. Putting the dots in is one part. Knowing where they are is another. So let's put Garrett's work test here. The full distance was 2 pi. Halfway in between is where we put that middle spot, that bottom of it. Where's that going to be at? Pi, yeah. That one's the easy one. There's usually at least one easy one.
And they get a little bit tricky.
And they get a little trickier. Okay? Let's take a look. Where's this dot going to be at? Pi over 2 is right.
Hey.
All right, now the hard one.
2 pi over 2. 3 pi over 2.
3 pi over.
Dang it.
Oh, man.
So close.
There's a lot here. So let's go back. I'm going to take a few steps back. Oh, you missed some fun times.
My good luck.
Take a few steps back.
Hey, Cole. Can you hear me?
Let's start right here. Okay? We determine where we're going to start using the phase shift. We determine where we're going to finish using the period. With those 2 pieces, I now use the fact that cosine exactly halfway through
Why did you miss?
gives us the bottom. So again, cosine starts high, halfway through hits the bottom, on the other end hits right back at the top. It cycles. Halfway in between those, it hits the middle. Again, this is how cosine looks. Cosine starts the top, ends the top, halfway in between hits the middle. It does those 4 things. So I duplicate that in my version of the picture, making sure the values correspond correctly. And then, the tricky part for us is usually just getting these other numbers right. Because this number is easy. It comes from the period. The rest we have to estimate using our values. So we know halfway between that is going to be at pi. Over here is going to be at pi over 2. And 3 pi over 2. Thank you, Scott, for that. That was fantastic. We got 5 dots. Let's make it look like cosine. Cosine is a nice curve. It starts by going relatively straight out and then curving down into that midline. Hitting that midline, coming down to the bottom, straightening out. Hitting that bottom, going back up through the amplitude, and ending right back at the top. A beautiful curve. And our second successful graph.
Hey.
You gotta shake it like that.
I know.
You gotta shake it like all the
Me either. Learn. It sucks. But I promise you, we'll make it through together.
And that was all my mouth.
You'll notice that each one of these follows a set of steps every time. We'll ask these steps every time. The tricky parts we've seen so far have been things like the values, not the concept. Oh, this value's in a weird spot, so that's going to make it tougher. Yes, it's going to do that. But the fact that halfway in between it does one thing, at the quarters does another, that concept holds through the entire time. Whether the period is 50 pi or 2 pi over 3, it's going to do the exact same thing every time. Halfway through it, it's going to do one thing. At the quarters, it's going to do a different thing. So, that's another one.
Another one.
Reset.
Hey, you can copy this one now.
Let's take that shaft machine. Keep going.
No.
No? I promise you. Cocaine for breakfast is not a good idea. Alright. Grab another one.
I think I'm good.
Please, no, sir.
As opposed to the whole one.
Oh.
Okay, well, now that we only have 2 days to do the homework.
Take your time. Take your time. Alright. Sine.
No homework this week, is that what I heard?
Sine of x minus 3.
Oh, that's not that bad.
So the whole thing's just gonna go down 3.
Yeah.
And that's it.
Yeah.
Okay, I'm glad you did it.
Yeah. That makes sense.
Alright. Take one piece at a time. Now, again, not all of these pieces have to be done, but these are good places to start if you want to get it right. So let's ask these small questions. Starting with question number 1, what's the phase shift? Or what I call the PS, phase shift. 0. It's not going to move left or right. There is no number being added or subtracted inside, so it's not going to move left or right. What about the next one, midline? Where's the midline?
-3.
At -3. Which means that it's going to be at the y value of -3. Which we'll draw here in a second.
So the
Amplitude.
is 0?
The amplitude, remember, the amplitude is usually a 1. It's whether it's different than 1 that matters. So the amplitude in this case is a 1.
I don't get that.
Because the normal place it goes is up to 1, down to 1, up to 1, down to 1. And so if it's not changing, we assume that's what it's going to do. So if there's not a number out front, it's going to stay at the normal spot of 1 to 1. All right, period.
Wait, then why was, for the first one that we did, why was it 0 then?
I meant to put no change, not 0. That was a mistake on my part. I will definitely have to fix that the next one. The period. So what I do is I take my b value, I plug it into this formula. So 2 pi over b. What's my b value in this case? In this case, my period is 2 pi. And we'll take 2 pi, draw this graph. All right, let's do this. I begin. Okay. First step, if I'm going to be graphing these, what do I do first?
Where you begin? -3.
A -3, the midline. This is going to determine everything else. Everything else is built off the midline. So that's at -3. So I come down here -3. At -3. There's my midline. So, boom. What's the amplitude going to do? No. It's always off of the midline. So if the amplitude's 1,
So go to 2.
it's going to go up to -2
Or -2.
and go down
To
to -4. So I come here. In red, there's my amplitude. Remember, amplitude is how far it goes up or down from the midline. All right, there's no phase shift. So where will this thing start? At 0, -3. On the midline, at 0. Where will it end? 2 pi -3. Look over here. At 2 pi. Okay, where sine starts by going up, down, and then back to the middle. So I found out where it's going to start and where it's going to stop. Okay, think of the picture of sine in your brain. It starts here. Up, down, middle. What happens halfway through the cycle for sine?
Midline.
It's back at the midline. So I come up here. Halfway through my picture, it's going to hit that midline again. And in this case, Where's that going to be at? Pi. In this first group, sine starts at the midline. What's the first thing it does? Goes up to the amplitude. Halfway in between, it goes up. Where's that going to take place? Pi over 2. Where does it go down?
3 pi over 2.
3 pi over 2? Yeah. We got our 5 dots. Last thing. Connect those dots. Sine starts by coming up to the amplitude, down to the midline, down to the bottom amplitude, and back up to the midline. There is one cycle of sine of x minus 3. So, in the few minutes we have left, let's review this concept and how everything fits together. We answer our 4 pieces at the beginning. These 4 pieces can be done kind of in any order, because again, we're going to answer these questions. That's our goal, is to answer all these pieces. We have to know where the midline is. We use the midline to define the amplitudes. With the amplitudes, we determine where it starts and where it finishes, using the phase shift and the period. And then we determine what happens at each stage in between, using the properties of sine versus cosine. We will continue this tomorrow. Come with graph paper. I'm ready to try it out. Ready in the class of tomorrow? I want to make 2 changes.
Let's just make all 4 changes.
Isn't that something? At first, it's terrible. At first, it's awful. At first, I want to die. But then over time, we know how the pieces fit together. And then it's not so bad.